Let's look at some examples with scientific notation. Scientific notation is something that you've probably looked at some in some science classes or maybe previous math classes. It'll come up for sure in chemistry. You'll do a lot of calculations where you'll have things given in scientific notation, or you need to report your answers in scientific notation. So remember that scientific notation is just a way to write answers that might be very, very large numbers or very, very small or lengthy decimal numbers in a little bit of a shorter form using multiplication with 10 to some exponent. So since we're looking at 10 to some exponent, that's why it falls in this section of properties of exponents. So first, let's take a number and write it or change it into scientific notation. So here we have 100,000 million billion 67 billion. Proper scientific notation form, we only put one number in front of our decimal place. So this is going to be 6.7, and then none of those zeros matter to us. So 6.7, and this is going to be times 10 to some power. Well, what power? If we put our decimal here at 6.7, we need to get it back to 67 billion. So multiplying by 10 moves our decimal one place each time we multiply. So easiest thing to do here is just count 1, 2, oops, let me do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We would need to move our decimal 10 places, so 67 billion in scientific notation would be 6.7 times 10 to the 10th. Now what if we have to do some calculations that involve numbers in scientific notation? Well, here if we're multiplying two numbers that are in scientific notation, remember that multiplication is commutative. So we can multiply whatever order we want. So here we have 7.2 times 10 to the 9th times 9.4 times 10 to the 8th. So we could move things around and make this 7.2 times 9.4 times 10 to the 9th times 10 to the 8th. You'll probably need a calculator to help you out with 7.2 times 9.4. That comes out to 67.68 times, you can use the properties of exponents to do 10 to the 9th times 10 to the 8th, add 9 and 8, and we would have 10 to the 17th. Now we need to make one little change here because we're not in proper scientific notation yet because we don't have 6.768. So we need to move that decimal back one place, which would be the same as dividing by 10, right? We would divide by 10 to get us there. So swinging that decimal to the left to cancel that out and make it the same value still, we also have to multiply by 10. Okay, so if we divide by 10 and multiply by 10, we're not changing the value of that number, but maybe just how that number looks. So if we swing that decimal back one, 6.768 times 10 to the, well, since we did 10 to the 17th times a 10 to the 1st, that makes this 10 to the 18th. Okay. On to that third example, we have 2.1 times 10 to the negative 8th times 4.6 times 10 to the 4th. So if we do 2.1 times 4.6, let's do that part first. That comes out to 9.66 times 10 to the negative 8th times 10 to the 4th. We're multiplying those two exponents, they have the same base. So negative 8 plus 4 gives us 10 to the negative 4th. And that would be that answer in scientific notation. Now, if you don't like having to adjust it like we did here, um, you are able to just plug this in your calculator and it should spit it out for you in scientific notation. So if you have questions about how to do that or what the proper way to plug this whole piece into your calculator is, I can help you out with that, because it's not always straightforward. There's maybe some things that you have to be careful with trying to plug something like that into your calculator.